Welcome back to my PixInsight tutorial series, and today we're going to be talking about background extraction, and I'm going to show you two different methods of neutralizing your background in your Astro images. So we're going to talk background extractions, and what I have right here is an image of the Macarian chain. This is stacked but otherwise unprocessed. As you can see, it's still in its linear form, it has not been stretched. And as you can see, this image right now has a rather noticeable gradient. We can see how there's very light yellowish color here and very dark up here. And we're gonna try to fix that today. And we're gonna do it with multiple different methods, because as with many things in PixInsight, there is many ways to do the same thing. And that also goes for background extraction. So there are two processes we're gonna talk about. If we go up here to the process window, you can see here we have one that's called background here, and we have one's called automatic and one's called dynamic. You can of course also go out to the process window out here, and you will find them here as well. So this is the same view. I find this easier because you can just go here and we can search for background if we're interested, and it's just a little bit easier. But anyway, now we're going to start with the automatic background extraction, and we're going to do that because that's probably the easiest to use. If we open it up here, we get a bunch of different settings here, and most of it you don't have to worry about. Some of it might even be collapsed here when you start out. My recommendation would be don't fiddle with these settings at all. Keep them as is. And if you're having trouble and you're not going to get a good result, then I recommend you go over to the dynamic, which is a bit more complicated, takes a bit more time. But if the automatic doesn't work with the default settings, you're probably better off doing it manually anyway. The only setting you do need to change is the correction down here. By default, this will be set to none. And you can see here, if I just take this little triangle, drag it over there, and run it, absolutely nothing happens to my picture. My picture stays the exact same as it did before. I just get a new image. And if we take a look at this image and we just quickly stretch it, we can see that it has now tried to emulate the background of my image. And but it hasn't actually corrected it. And that's because I haven't chosen a correction method down here. You would either use subtract or division, and some people like one, some people like the other. Keep these here. You can replace target image. I probably wouldn't. It's nice to keep the target image so you can go back to it in the future. And we can also click discard the background model if you don't want to see the background model. But again, I think it's nice just to have a quick look at it just to see what it does, so that it didn't do anything completely weird. So I would just not bother with these at all. But we can try to just do here. Now drag it over. What we can see we get now is we get two images up instead. There we go. We still get our background model, looks like that, but now we also get the corrected image, which now looks like this. And as you can see, it actually done a rather decent job. You can see here we have a pretty even background now. There's still a lot of noise in this image and other things that needs to be corrected, but overall, the background has been corrected. And if we just take and compare the before and after, let's do that. You can see here, definitely a lot happened. It might look like, I think that maybe it over brightened that a little bit. I think that's just because it looks like it brightens it, but I think it's actually pretty flat. Let's just quickly try to do it with division, just so we can see if there's any noticeable difference. So I'm gonna take the original here, the one without the background being removed. I'm gonna apply it, but with the division correction instead. Stretch it, and now let's try to blink the subtraction and the division on top of each other. And as you can see here, as we swap between them, I don't know about you, I can't see any difference at all. Like, it looks very, very similar to me. But your mileage may vary. It may be that one works better than the other for you, but in this particular case, I cannot see a difference with the automatic one. So that's how you use the automatic background extraction. And again, if you're not happy with the results you get out of this, then we need to get out the big guns, and we need to go up to scripts again, and we need to go in, or scripts, sorry, processes, background, and we need to use the dynamic background extractor. This is a lot more complicated, but with a lot more power, and that also means you can probably get a lot better result, as you can now begin to fine-tune this yourself. If you've been using the background extractor in Cyril or in Graxpert, then you'll be very familiar with what we're going to be doing here in a second. Because what we do is we click on an image, we get a crosshair, and now we need to set sample points, and it's going to use these sample points to compute the background. So our job now is basically to put down squares like this, and we get a little like a view of the square here. And if we take this square and move it around, what you can see here is if I move it over a star, you can see how it shows up in black. That means those pixels has been rejected from the background. So it's doing some live rejections on what it thinks is background and what it thinks is stars, and the stars are being rejected. So you don't necessarily have to be too scared about putting it over a star the same way that you have in Cyril. Like this would be, most of the star would be rejected. I would still recommend that you try to put all your boxes away from the main stars. And especially if you have a picture like this, where you can see we have this faint halo here around the galaxy over here. If I were to put, oh, wow, this is all over the place. If I were to put down a box there, you can see it does show up in red, indicating that it looks at this as a bad sample, and does that because you can see how much black there is. A lot has been rejected, so say this is not a good spot for it. But still here it would actually accept it, saying this is fine. But this would still cause issues because we're still quite close to the halo here of the galaxy. So you still need to be careful with the placement of the points. But we briefly talked about this view here. This is actually quite important. Let's just delete a few here and just go and play around with this. Okay, so we have our square here, we can move around, and now we have some parameters here under the model parameter. The tolerance basically indicates how far away from the mean value a pixel have to be. So you can imagine it does a histogram of all the pixel values in the picture. And then it says, okay, based on those pixel values, how many standard deviations does it have to be away from that mean before the pixel is rejected? So if I increase this number here, let's put it up to, I don't know, 2, we can see that now it lightens up a lot of it, a lot less was rejected as we widen that area. I think 0.5 is a bit low, but as you will see here, if you see a lot of black in your background, if we put this back to 1.5, you can see even here, I still see quite a few black pixels around. That's an indication that you probably have this value too low, and you might want to try to increase it. I can show you another way to determine what the correct value is for your picture here in a second. But this is just a good way to just check it. And the same with the shadow tolerance. This is specifically the low end, how tolerant it is there. You might also want to increase that if you want to try to get like a little bit more information out of the background. So for now, we're just going to put this back to the default so I can show you another way to determine whether you have whether you set these parameters correctly, because we don't have to sit and place all these sample points ourselves. Down here on the sample generation, we can ask it to do this for us. Right now it says 15 and 10, and if I click generate, not a whole lot happens. Why? And that's because it couldn't really find enough samples in this image because the gradient here is quite severe. So you can see already now, actually, it keeps throwing the same error. It says here that only 3 samples were generated. This is often a consequence of a too strict parameter. So that basically says my model parameters here are too strict, so it can't generate enough samples because now I need to increase it. So let's put this up to, let's say, maybe 1. And let's try to generate again. There we go. That's a lot better. You can see how it's generated points now based on the radius. That's basically the size of the box. So if I made this, let's say 25 and click generate, we get bigger boxes. 15 is usually fine. And the one here that says 50 sample points per row is just the density of the grid. So if I put this down to 25, we get a less dense grid. We can control this. 50 as it was there is probably a bit too much. I think this kind of like 25 is a pretty good balance point here for me. We can see here that it still doesn't fill out the corners and still also has a few gaps up here. And then again, that's another indication that our tolerance here is still a bit too low. So we can try to increase this even further and go up to 1.5 and then click generate. And now we actually fill the grid rather nicely. So now that we've done that, now we can try to again take the triangle and run it over here. And if everything goes according to plan, it should now, you can see here, just as before, it only gives us the background model. And I can already see there's some issues with this. Notice this light blob here. That's that light from that galaxy. So I can already, just by looking at this, I can see there is some issues as it's not even as you would expect. But we can just go ahead and get it to actually correct it. Because just as with the automatic down here in target image correction, you have the option for subtraction and division. You have the exact same options as you had before. Now notice here, again, we have it stretched, but look at that black halo around the galaxy here. We zoom in on this. You can see how the area, the area around this galaxy here is noticeably darker than the area around it. Now that's an indication that we have a few issues with our sample points. And the issue is, as you can see, as we talked about, that there are sample points that are too close. They have gone into the galaxy itself. So I would just take these points, move them away from the galaxy. That one's probably too close as well. Move that up there maybe. Move this, just clear some space. This one is kind of stuck here in between, so I'm actually gonna completely delete that. Okay, as again, if we blink these two models, this was the old one, and this was the new one. You can see how we still have a little bit, so we could probably still fine tune it a bit, and we have a little bit here, maybe too. But you can see we've drastically reduced the lightness in this area compared to what we had before. And let's see what that means for our final image. So let's go ahead and let's auto stretch the image now. And as you can see, we now have a much better result, and we don't have as much, still a little bit of dark haloing around that. So I would probably still fine tune and maybe try to even clear even more space around this, these galaxies here to be absolutely sure that we're not getting any light from these into a background. But this is the kind of power you get with the dynamic. You can really sit and fine tune and customize it to your specific image. See, now that's a lot better now. Maybe there's a bit in there, but overall I think this is pretty good, at least compared to what we had before. First we have the automatic and the dynamic. I mean, the changes here when we blink between them is subtle, but when you have them like this, where you blink on top of them, you can absolutely see that the dynamic has got it more even than the automatic did. In this case, they're probably similar enough that I would probably be able to work with this. But again, if you spend the time, you do get a slightly better result with the dynamic background extraction than you do with the automatic. Now, I hope this was helpful, and I actually have one more thing that you might find helpful as well. This is my book called The Cosmic Field Guide, and this is the main way that I fund this channel is through selling this book. This is a handbook, a field guide that you take with you that's full of handy graphs and tables and tips and tricks and things that you might need as a astrophotographer. You can get this book at deepspacebooks.com, so go check it out. And as always, if you have feedback or suggestions for more topics you would like to see videos on, then the comment section is right below. I'm looking forward to reading your comments. Welcome to the first episode in my series on teaching you how to use PixInsight. We're going to start from scratch and we're going to work our way up through today's lesson. We're going to start out by talking about how you stack images. We're not going to be talking about all the other stuff like color calibrations and background.